Hello students, this is week number 5 and we are starting chapter number 2. Chapter number 2 having two non-algebraic or transcendental function like exponential function and logarithmic function. This chapter we will complete in 3 weeks, and in this chapter if we see we can divide it into 3 sections: week 5, 6 and 7. In this week we are going to discuss about exponential function. What is exponential function? What are the properties of exponential function? Then some questions and graphs of exponential function. This is week 5. Week number 6 we will study the logarithmic function, its properties and question based on logarithmic function. And in week 7 we will study the most important concept. What is the use of exponential and logarithmic function? The practical application we will study, and also we will learn how to convert the exponential function into logarithmic function and logarithmic function into exponential function. This is very important concept we need to learn. But before all these things, we will study the exponential function. So question number 1 comes in our mind. What is exponential function? So a function f such that r to r is said to be an exponential function if fx equal to a power x. Clear? Like, what is the domain of this function? The domain of this function is R. What is the codomain of this function? The codomain of this function is R. And if x is the independent variable, then the dependent variable becomes here is a power x, fx. That is fx is equal to a power x. What is a here? Where a is a positive number, a is a positive number but not equal to 1. Please remember, a is a positive number and it is not equal to 1. If it is not equal to 1, then there are two possibilities. What are the two possibilities? Because a is positive, so a is greater than 1 but less than 1, because a cannot be 1. And possibility number 2 is a greater than 1. These are the two possibilities for exponential function. Fx is equal to a power x. If we see the examples of this, so there are 2 power x, 3 power x plus 1, 7 power 2x, 5 power 3x minus 1. Clear? 1 upon 2 power x, or we can write it 2 power minus x. 1 upon 3 power 2x, and this can be written as 3 power minus 2x. Clear? So for these functions, look, for these functions the graph is a power x, and for these functions the graph is function is a power minus x. So whether it is a power x or a power minus x, both are known as exponential function. Here we are considering a greater than 1, but here we are considering a less than 1 but greater than 0. Clear? In case of negative function. Okay, so this is about what is the exponential function. Now we will learn what is the graph in these two cases. Let us divide the screen into two parts. The part number 1 is a greater than 1 And what type of graph we have? If you see, this is x-axis, this is y-axis, and we always have a graph like this going up. Clear? So what is the point number one? Point number one is it is a increasing graph. So it is a increasing graph. Increasing graph when? When a is greater than 1. Number two, what we conclude? If we put pen here, it is moving, moving, moving. We are not give any break. So it is a continuous graph. It is a continuous graph. There is no break in the graph. What is number three? Comes in the domain. Domain, what I told you? I told you domain is the values on x-axis. Clear? You see graph is in the positive side, graph is in the negative side. And it is defined for every value of x. So the domain is R. The set of real numbers, positive and negative both. And if we come here, point number 4 is the range. Range means the values over y-axis. So look, there is no graph here, no graph, no graph, no graph, no graph. That means negative side, no graph. Graph is only positive side. So the range is R plus. R plus means positive real numbers. Clear? These are the 4 important properties of exponential function. On the other hand, if we have 0 is less than a is less than 1. Here the graph is a power x. Clear? Here the graph we are going to draw is a power minus x. It is x, it is y, and it will be how much? It will be like this one. It will start like this and it will end like this. This is a power minus x. A power minus x. Clear? Or because a we have chosen this, so we call it a power x. But this can be written as a power minus x. 1 upon a. Okay. So what is this? If you see, as the x is going down, the graph is coming down, 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 down. So this is what? Point number 1, it is a decreasing graph. It is a decreasing graph. Point number 2, it is continuous graph. There is no break. Continuous graph. And number 3, if you see the graph lies on both sides of x-axis. The graph is here, the graph is here. Clear? So the domain is R, while the range in this case is, if you see, the range is, because no graph here, negative side, only positive side. So the range is R plus. So you need to just give attention here. If a is greater than 1, the graph is increasing. If a is less than 1 but greater than 0, then the graph is decreasing. Rest 3 things are same. Okay. So before we start the questions based on exponential function, we need to study the properties of exponents, properties of powers, properties of exponents. What are the properties of exponents? If we see a power x, clear? What this a called? A called base. What this x called? It is called exponent. And in a general, we call it power. A power x. Clear? So x is exponent, b is the base. Sorry, a is the base. Clear? So based on this exponential function a power x, we have 7 to 8 important properties. Property number 1. What is the property? If a power x into or you can generally we write constant numbers a power m times a power n, because base are same a, so the powers are plus. For example, 3 power 5 times 3 power 2 times 3 power minus 2. Clear? If we see here is 3, 3, 3. So powers always plus. 3 power 5 plus 2 plus. What is this? This is plus. We are making plus. It is negative. That is another story. 3 power 5 plus 2 plus minus minus. Clear? So how much is the answer? 3 power 7 minus 2. So 3 power 5 is the answer. This is property number 1. What is property number 2? It is, sorry, a power m upon a power n. Then it is a power m minus n. If they are in division, so powers means exponent minus. Like 4 power 3 upon 4 power 7. So what will be answer? 4 power 3 minus 7. That is 4 power minus 4. This is the answer. This is property number 2. What is property number 3? If a power m, power n, exponent above exponent, then exponent always multiply. For example, 2 power 3 power 5. So how much it will be? 2 power 3 times 5, that is 2 power 15. And similarly, if I take 4 power minus 2 power 3, so whether negative or positive, it doesn't matter. Exponent multiply exponent, minus 2 times 3. So 4 power minus 6. This is the answer. Properties of exponent. Now property number 4 is, what is property number 4? It is a power 0 is equal to 1. Any number with 0 exponent is always 1. 2 power 0, 1. 3 power 0, 1. Minus 6 power 0, 1. Clear? You take any number, positive or negative. Even you take 1 upon 2 power 0, it is 1. You take any number, if the exponent is 0, the answer is 1. Now we come to property number 5. Property number 5 is ab power m is a power m, b power m. What does this mean? If say I am writing 3x power 4, what is the answer? 3 power 4 x power 4, and 3 power 4 is 81 x power 4. So this is how we are, if two numbers are in multiplication and their exponent is 4, how we write? We can write this one. Property number 6, a upon b to the power m. So it is a power m upon b power m. Like for example, if I am writing 2 upon 3 power 3. So what is the answer? 2 power 3 upon 3 power 3. 2 power 3 is 8, 3 power 3 is 27. So 2 upon 3, 2 divides 3, and the exponent is 3 here. So 2 exponent 3, 3 exponent 3. So 2 power 3 means 8, and 3 power 3 means 27. Now the last property is very important. If we have any, say, a power m, we want to take it into denominator. So it will change into a power minus m. Or if we have a power minus m, it change into a power m. This we use at many places. Clear? For example, what is the value of 3 power minus 2? The value is 1 upon 3 power 2. That is 1 upon 9. So if we want to change the exponent into positive from negative or negative from positive, we need to take it into numerator or denominator accordingly. Clear? What is the value of 1 upon 4 power 3? If we want to write in numerator, it will be 4 power minus 3. Got it? So this is how we use the exponential properties. But there are some radical expressions also. Radical means where powers are in fraction. Radical expressions. Radical function, you can say. It is, say we are writing square root a. What is this? Square root a. If we are not writing anything, that also shows 2. Nothing means 2. So it is a power 1 upon 2. Remember this. And if I write this n, a. So this is nth root of a. And nth root of a means a power 1 upon n. So what is n? Order of the root. Nth order of the root. Nth root. So order of the root is n. Clear? Now I will explain you some of the questions that we ask in exam, and generally we ask them for 2 marks. For example, example number 1. What if 2 power x minus 3 is equal to 32? Find x. So here is what? 2. So we need to write 32 in the powers of 2. So 32 is 2 power 5. Because exponents are, base are same. So exponent, like I need to explain this property. If a power x is equal to a power y, then always x is equal to y. Remember this. If base are same, then and they are unequal, exponent will also be same. So this implies x minus 3 is equal to 5. And x minus 3 is equal to 5 means what? X is equal to 5. Shift this negative 3 here, plus 3. So what is the answer? Answer is x is equal to 8. This is how we find it. Clear? Now another example we will take. I will take exam questions from exercise of the book, and this is question number. This is not example, this is question 1 over page 37. So question number 1 is 5 power x plus 1 equals to 625. So 5 power x plus 1 equals to, you need to write 625 as powers of 5. So how will do it? Just try to learn. 625. So it will be 5 multiply 5. Clear? Multiply 5. Multiply 5. How many times we multiply? We multiply 4 times. So it is 5 times 4. Clear? Base are same, 5, 5. So powers will also be same. X plus 1 equals to 4. And this implies x is equal to 4 minus 1. And this implies x is equal to 4 minus 1 is 3. Clear? So this is how we are getting it. Another example we will take, it is question number 2. Part number 2. 3 power x minus 2 is 243. Now what is the base here? Base here is 3. So let us take calculator and okay, simplify this. Now we'll multiply 3 times 3. 2, 3, 4, 5. So it is 3 power 5. So it is 3 power x minus 2 is equal to 3 power 5. Now base is same. So powers will be same. X minus 2 is equal to 5. X equals to 5 minus 2 will change into plus. So this is x is equal to 7 is the answer. Got it? Okay. One more question we will take. That is question number 3. I will tell you later. 4 you can do. 5. Question number 5. It is 7 power 3x equals to 49 power 5 minus x. This is clear. Now you need to write, it is 7 power 3x. So you need to write 49 as a 7. So it is 7 power 2, 5 minus x. Now you see here, power above power, exponent above exponent. So how we doing? This is 7 power 3x and the exponents multiplied 2 into 5 minus x. So 7 power 3x equals to 7 power, multiply inside, 2 times 5 is 10 minus 2x. Now the base is same. So powers we add, 3x is equal to 10 minus 2x. Now club x together. So 3x, shift this side, plus 2x equals to 10. And 3x plus 2x is 5x is equal to 10. Divide by 5. How much we'll get? 5 cancelled by 5. X equals to 10 divided 5 is 2. So the answer is 2 in this case. Clear? So this is when we get exponent above exponent, then we solve like this. We need to multiply the exponent. And the last question I will take in this series is question number 1 part 3. What is that question? It is 27 to the power x plus 1 equals to 9 power 2x. If you see this question, in this question 27 and 9, neither we can change 27 as a powers of 9 nor we can change 9 as a powers of 27. So we need to find the multiple of 9, 3 times 3, and 27 is 3 times 3 times 3. That means 29 may be written as 3 power 2 and it is written as 3 power 3 and both have same base. So we need to break it like this. 3 power 3 is x plus 1 and 3 power 2 is 2x. So now exponent above exponent. So multiply it. 3x plus 1, 3, twice of 2x. So it is how much? Multiply 3 power 3x plus 3, multiply here equals to 3 power 2 times 2, 4x. Clear? Now base is same, so 3x plus 3 equals to 4x. Clear? This is a small number, so we will shift this number here. So 3 is equal to 4x minus 3x. This implies 3 is equal to x. So what is the value of x? The value of x is 3. And this is very important question. Why very important question? Because this type of question we generally ask in the exam. Clear? So this is about the exponential function, the properties of exponential function, and then we solve very little questions based on exponential function. So that's all in this lecture. In the next lecture, we will meet with the graphs and other topics of the exponential function. Thank you.